So the next topic we are going to cover is quadratic inequations, which is the second topic written above. So a quadratic inequation is an inequality of the type ax squared plus bx plus c less than equal 0, greater than equal to 0, less than 0, or greater than 0. And of course, a is not equal to 0, because otherwise we would be back to linear inequalities, and a, b, and c belong to the set of real numbers, and x also belongs to the set of real numbers. So this is actually a real quadratic inequation. So earlier we were dealing with equations when instead of these four signs of inequality we are having the equal sign. So ax squared plus bx plus c was equal to 0 or equal to something, whereas here we are dealing with inequalities. So we've already covered a lot of concepts on which all of this will be based. For example, the concept of the discriminant of the quadratic equation. So to recall, the discriminant of the quadratic equation related to this inequality, d equals b squared minus 4ac, or so the square root should not be there. So the discriminant d is b squared minus 4ac, and based on the value of the discriminant and the value of the coefficient of x squared a, there can be many different cases which are possible. So let us deal with all these cases. So case 1 is when your a is greater than 0 and d is greater than 0. So a greater than 0 means that the parabola opens upwards, and d greater than 0 means that there are two distinct and real roots. So what does this mean? If you were to draw the x-axis and the parabola, so the parabola has to open upward and it has to have two intersections with the x-axis. So it will look something like this. And these are the two distinct roots, alpha and beta, and as I have drawn it, alpha is less than beta, because alpha is on the left side on the number line and beta is on the right side on the number line. So then if a is greater than 0 and d is greater than 0, we see that there can be different cases. When x is less than alpha, so this part of the number line, the value of the function ax squared plus bx plus c, which is plotted here, is always above the x-axis, meaning that it is positive. And if x is greater than b, so this part of the number line, again the function is positive. So the function can be positive if we are here or here. On the other hand, the function is negative if you are between alpha and beta. So any inequation you can solve if you have it in the form ax squared plus bx plus c by just recalling what the value of a and what the value of d are. Based on these values, you will be able to make a mental picture of this parabola, and consequently you will be able to write what the solution, whether the solution is positive or negative at any point. So for example, if you were looking for the solution of fx greater than 0, then you would be able to say that x belongs to the set of real numbers which lie between minus infinity to alpha union the set of real numbers which lie between beta and infinity. So if you notice here, I have used a parenthesis here. The other option which I could have used were square brackets. So square bracket means that we are including the point here, whereas here, because this is a strict inequality, so fx has to be strictly greater than 0. That's why we can't include the point alpha. If we were to include the point alpha, we would actually be solving the inequality fx greater than equal to 0. So if you were looking for the solution of fx greater than equal to 0, then your domain would be minus infinity to alpha, where alpha is included. So that's why you have the square brackets, and you would also include beta up till infinity. So this would be the solution if your fx was greater than or equal to 0. On the other hand, if fx was less than 0, then x would lie between alpha and beta. And if fx is less than or equal to 0, then it means we can include both alpha and beta. So you can use square brackets. So another way of writing this is alpha less than x less than beta, or alpha less than equal to x less than equal to beta. So these are the 4 different inequalities which are here, and we have documented the solution to each of these 4 cases just based on the signs of A and the discriminant. So knowing just the values of A and the discriminant, you will be able to solve any equation of one of these 4 kinds. So let's move on to the second case. Case 2 is if A was less than 0, but D was still greater than 0. So in this case, you know again that there are 2 distinct roots, but the parabola opens downwards. So the parabola is something like this, and you have alpha and beta. Again, remember that alpha is less than beta, otherwise all of this would get messed up. So whenever you have 2 roots, always make sure that you first list the one which is smaller and then the one which is larger, because on the number line you move from the left to the right. So in this case, if you wanted to solve for the inequality fx greater than 0, the solution would be x belongs to the set between alpha and beta. If you were to solve for fx greater than or equal to 0, you could also include the endpoints of this set. So you could use square brackets to denote this. And if you were to solve fx less than 0, that would be this part of the number line and this part of the number line. So you would include the numbers going from minus infinity to alpha union beta to infinity. So the union means that you need to combine. So union is basically an OR operator. So it can be x can either be here or it can be here. And finally, if fx you wanted to solve for less than equal to 0, then you would be able to include these 2 points, because at these points fx is exactly 0. These points are by definition the roots of fx, or the intersection of fx with the x-axis. So the solution would be x belongs to minus infinity to alpha included, so you use the square brackets, and beta to infinity. So there are 2 more cases which are fairly straightforward. So this is the case when your A is greater than 0 and D is less than 0. So in this case, because D is less than 0, there are no real roots. So the parabola would look like this. So your fx is greater than 0 for all r. So fx is greater than 0. So the solution is all the real numbers. And so if you were to solve fx greater than or equal to 0, that would also be the set of real numbers, because it can never be 0. And the solution of fx less than 0 would actually be the null set, because there is no possible real number in which the value of fx can be negative, or even if you were to do less than or equal to, then you would still land up with the null set. And let's, for completion, also write case 4 here, which is when A is less than 0 and D is also less than 0. So in this case, the parabola opens downwards, so the fx is always negative for any given value of real x. So fx greater than 0, so this will be the null set, and fx less than 0, this could be any possible real number on the number line. and also fx less than equal to 0 could also be any real number, because fx equals 0 never happens, so it never really touches the x-axis. So based on intuition and just the values of a and the discriminant, you can solve any quadratic inequation. So now we are in a position to do a solved example. Solve the quadratic inequality. Solve for x. X squared minus 2x minus 15 is greater than 0 for, and x can only be belonging to the set of real numbers. So to start with, the polynomial associated with this inequality is x squared minus 2x minus 15. So let us denote that by f of x. So let f of x equals x squared minus 2x minus 15. So if you compare this with ax squared plus bx plus c, you already know that a equals 1, which is greater than 0, which means the parabola would open upward. And you can also compute the discriminant, which is b squared minus 4ac. So b squared is minus 2 squared minus 4 times 1 times minus 15. So this would be 4 plus 60, so this is 64, which is greater than 0. So this means that a is greater than 0 and d is greater than 0. The parabola opens upwards, and there are two distinct and real roots of this equation, this quadratic equation, fx equals 0. So what are the two roots? So the two roots are given by minus b plus minus square root of d over 2a. And if you were to plug in the numbers, so b is minus 2, so minus b is 2, and d is 64, so square root of d is 8. So then you would get x is minus 3 or 5. So these are the two roots of the associated equation. If you were to draw this on the xy plane, then it would look like this. So this would be x equals minus 3, this would be x equals 5, and you are drawing it facing upwards because a is greater than 0. So we are looking for all those numbers which are real and for which x squared minus 2x minus 15 is greater than 0. So just by looking at this, we are looking for points which are above the x-axis where y is greater than 0. So the solution is x belongs to the numbers going from minus infinity to minus 3, not included, because we are looking for a strict, this is a strict inequality. Union, the set of real numbers going from 5 to infinity. So this is the answer or the solution for x for this given inequality.